Catching Super Heavy and then reflying it within just 37 days. That was SpaceX's biggest achievement with Starship last year. But guess what? That record may soon be shattered. Yes, SpaceX is gearing up for an even crazier turnaround time with Flights 8 and 9, pushing the limits like never before. And they're not stopping there. Bold new plans are on the horizon. So what exactly is SpaceX planning? How are the preparations coming along? Let's dive right on in on today's episode of Great SpaceX to find out. Once again, we have to look back at the incredible feat SpaceX achieved late last year. On October 13th, with Flight 5, SpaceX successfully recovered the Super Heavy booster for the first time, using the most challenging method, landing with the Mechazilla arms. This was a crucial step toward proving the viability of this innovative landing approach and unlocking the full potential of Starship's reusability. Just over a month later, on November 19th, SpaceX launched Flight 6, marking the fastest turnaround in the program's development, just 37 days between flights. This wasn't just a record for Starship, but a remarkable achievement for any rocket still in development. However, if there's one thing we know about SpaceX, it's that they never settle. They're always pushing for faster, bolder, and more ambitious goals, and now we're on the verge of witnessing yet another breakthrough. The highly anticipated Flight 8 is currently scheduled for February 28th. If there are any delays, it might slip into early March, but the focus is now entirely on this upcoming launch. However, an exciting new development has just emerged. SpaceX has received an FCC license for Starship Flight 9, and the first major detail stands out. The start date of operations is listed as March 14th. For those who might not remember, March 14th was the launch date for Flight 3 last year. While the FAA ultimately determines the launch approval, the FCC license is still a strong indicator of what to expect. Notably, the FCC license for Flight 8 started on February 24th, just 4 days before the anticipated launch. If this pattern holds, Flight 9 could be much closer than we initially thought, possibly even launching within March. Now let's talk about the mind-blowing possibility this presents. If Flight 9 lifts off as early as March 14th, the turnaround time from Flight 8 would be an astonishing 14 days. That may be an optimistic scenario since it's an extremely aggressive timeline, but even if it launches on the last day of March, it would still be just 31 days apart. My personal prediction, a launch around the 21st of March, less than a month after Flight 8. No matter what, it's looking more and more likely that SpaceX will shatter last year's 37-day turnaround record. This rapid cadence is a major stepping stone towards SpaceX's ultimate goal. The company is targeting 25 Starship flights throughout 2025, ramping up to an incredible 400 flights per year within the next 4 years. In the more distant future, we could see multiple Starships launching every single day. But it's not just about frequency. These flights are becoming more complex and ambitious. Flight 8 will follow a similar sequence to Flight 7, refining key objectives like deploying payloads, reigniting the engines in space, and attempting another Super Heavy landing with the Mechazilla arms. However, new upgrades will also be put to the test, especially with ship's reentry and landing. The V2 updates, including improved flaps and a more resilient heat shield, will be crucial. Additionally, SpaceX must verify fixes for the issues that arose during Flight 7. This makes Flight 8 a pivotal transition point in the Starship program, combining both established and new mission goals. So what about Flight 9? Many initially assumed it would involve another ocean landing for ship, serving as a final rehearsal before an actual Mechazilla catch attempt. But the FCC license has just revealed a game-changing possibility. Under the Purpose of Operations section, the document states the first stage booster and the second stage will either return to the launch site or perform a water landing. Yes, you read that right. While the wording leaves room for multiple possibilities and interpretations, this is the first time an official document has even suggested that ship could return to the launch site. If this is indeed SpaceX's plan, it would mean a full recovery attempt for both the booster and ship, potentially making Flight 9 the first complete reusable Starship mission in history. To prepare for this, SpaceX has already been reinforcing ship with crucial modifications. If Flight 9 successfully lands both stages with Megazilla, it would mark a historic moment, proving full reusability for a space launch system, something no other company or space agency has ever accomplished. The next few weeks will be thrilling as SpaceX pushes the boundaries of what's possible with Starship. Will they break the turnaround record? Will Flight 9 be the first fully reusable mission? The potential for history-making moments is higher than ever. If you're as excited as I am, well, drop a wow in the comments. And don't forget to like the video and subscribe to our channel to stay updated on SpaceX's groundbreaking journey. Now, for SpaceX to achieve its ambitious goals, several key factors must align. First and foremost, the success of the upcoming Flight 8 is crucial. The results of the mission will directly influence the timeline and objectives of Flight 9. Initially, Flight 8 was expected to be the first attempt at catching Starship using the Megazilla arms, but issues encountered during Flight 7 forced a change in plans. Now, SpaceX must first master several critical objectives before advancing to the next phase. The primary goal remains securing a successful Super Heavy landing on Megazilla. While SpaceX has already achieved successful soft landings twice, refining this process is essential to ensure reliability for future missions. Perfecting this maneuver will pave the way for more ambitious recovery strategies. Next, SpaceX must demonstrate its ability to complete key orbital operations. These include deploying payloads and successfully relighting a Raptor engine in space. Two tasks that will be integral to many future missions. The ability to relight engines in orbit is especially critical for refueling operations, deep space missions, and even lunar landings. By prioritizing these objectives now, SpaceX can shift its focus to improving re-entry and landing procedures in future flights. Speaking of re-entry, this phase will be one of the most scrutinized aspects of Flight 8. The upgraded flaps and reinforced heat shield must withstand the extreme conditions of atmospheric re-entry. If successful, SpaceX can use the data to refine Flight 9, which could potentially mark the first attempt at catching Starship with the Megazilla arms. However, before that step, a controlled ocean landing must first be perfected. This test will provide valuable insights into Starship's descent and stabilization capabilities, ensuring the flaps and engines are functioning optimally before incorporating the chopsticks into future recovery plans. All of these factors make Flight 8 a pivotal mission. Its results will dictate whether Flight 9 can launch soon after and incorporate the long-awaited catch attempt. Beyond the mission objectives, the timeline for Flight 9 will also depend on the readiness of the necessary hardware. Both S-35 and B-16, the Starship and Super Heavy booster assigned to the flight, must be fully tested and integrated before launch. As of now, production of these vehicles appears to be complete. B-16 is expected to begin cryogenic testing soon, ensuring its structural integrity under extreme conditions. Afterward, it will return to the production site to receive its Raptor engines before undergoing static fire tests. S-35 will follow a similar path, though its static fire test will likely take place at Massey, allowing for more flexible scheduling. Both vehicles must complete their respective tests efficiently to stay on track for an early launch window. Meanwhile, SpaceX is also making rapid progress on ground infrastructure. Beyond the routine refurbishment of Pad A, attention is now shifting to Pad B, which has just received a significant upgrade. The chopstick arms, which will eventually catch Starship, have been fully installed. Additionally, in the latest update, a water tank for Pad B's deluge system has arrived, signaling that final installations are nearing completion. Once the infrastructure is in place, Pad B must undergo extensive testing to ensure it's fully operational and ready for the high-stakes catch attempt. With so many moving parts, Flight 9's schedule remains fluid. However, if everything proceeds smoothly, hardware tests, ground system upgrades, and Flight 8's success, It's entirely possible that Flight 9 could take off by late March. That would be a game changer. If SpaceX follows through with its plan to execute multiple high-risk objectives in such a short time frame, we could witness one of the most exciting test flights in Starship's development history. Are you ready for it? Let us know in the comments and stay tuned for what's next. And for our final bit of today's update, which is also related to upcoming launches, let's take a moment to talk about China's ambitious Tianwen-2 mission. According to recent updates, Tianwen-2 is set to be a groundbreaking mission focused on collecting and returning samples from a near-Earth asteroid. On the 20th of this month, the China National Space Administration announced that the spacecraft had been successfully delivered to the Xichang Satellite Launch Center, marking a major milestone in its preparation. As for the launch timeline, CNSA has now a more flexible schedule for the first half of this year. This is a slight shift from the previously estimated launch window of May 2025. The mission will still be launched aboard a Long March 3B rocket, and according to the latest reports, everything is in good condition with testing currently underway. Tianwen-2's primary target is the asteroid Kamo'olewa, or 2016 HO3, a small near-Earth object measuring between 40 and 100 meters in diameter. This asteroid is particularly fascinating because it is believed to be a fragment of the moon, possibly ejected into space after a collision. If this theory is correct, studying its composition would provide critical insights into lunar history and future lunar exploration. The spacecraft aims to collect and return 200 to 1,000 grams of material by 2027. After completing this mission, the main spacecraft will continue its journey to study 311P/Pan-STARRS, a main belt comet. Beyond its scientific goals, Tianwen-2 represents an important step in China's broader Tianwen program. Tianwen-1, launched in 2020, successfully sent the Zhurong rover to Mars. Following Tianwen-2, the program will move to even more ambitious projects. Tianwen-3, scheduled for 2028 or 2030, will attempt to return samples from Mars, while Tianwen-4 is expected to send spacecraft to explore Jupiter and Uranus. Clearly, China is advancing rapidly in space exploration. I can't wait to see how NASA and SpaceX respond to these daring moves. The future of space exploration is shaping up to be incredibly exciting. And this has been Kevin with Great SpaceX. Don't forget to like the video and subscribe if you haven't already to stay up to date with yours truly in the latest details of SpaceX's progress. 2025 is set to be a breakthrough year for Starship, with bold and ambitious missions ahead. One key milestone will be the first attempt to catch SHIP, a major step toward full reusability. While the challenge is immense, SpaceX is actively preparing and refining its strategy. So, how is the progress going? Right now, we're on the path to Flight 8. Just a few months ago, many expected that SpaceX would attempt a ship catch during this mission. However, after analyzing the results of Flight 7, it's clear that we'll have to wait for a few more flights before witnessing that milestone. The next flight, Flight 9, has just seen its first scheduling details emerge. According to the FCC's licensing, the approved launch window spans from March 14th to June 30th. While some may question the reliability of FCC licenses, it's worth noting that their recent approval for Flight 8, no earlier than February 24th, turned out to be quite close to the actual launch date. One of the most significant changes for this mission is the potential reuse of a booster, most likely B-14, which successfully returned after Flight 7. Additionally, this flight carries major implications for the future of Starship, as it will test the possibility of returning both stages to their launch site. Preparations for this ambitious milestone are already underway. While SpaceX is busy finalizing preparations for Flight 8, the company hasn't lost sight of its long-term goal: catching and returning Starship using the Megazilla Tower. Recent developments at Mega Bay 2 suggest that critical upgrades are already in motion. At Mega Bay 2, where key prototypes like Ship 34, 35, and 36 are in various stages of assembly, a new system has appeared. Notably, an additional protective plate has seemingly been installed on S-35's catching points. This modification was observed when S-35 was lifted onto its stand, hinting at a structural reinforcement for the future catching system. S-34, which has already completed assembly, lacks a catching system, suggesting that SpaceX has no intention of testing this feature on this prototype. Meanwhile, S-36 is still under construction, making it too early for such installations. This leaves S-35 as the most likely candidate for these upgrades. The protective plate itself has a shield-like shape with a square hole, which directly corresponds to the opening seen on S-35. Additionally, it features multiple tiny holes, likely designed for the installation of heat shield tiles. Given that there are 2 catching points on either side of the ship, it's reasonable to expect a second protective plate to be installed as well. This would ensure comprehensive protection around the catching mechanism, increasing both durability and reliability. This upgrade suggests that SpaceX is reinforcing S-35's catching system in preparation for a future flight. Initially, it seemed likely that SpaceX would test the existing system under real-world conditions, especially through the intense stresses of re-entry before making refinements. However, with this new addition, it appears SpaceX is opting to strengthen the system right away rather than waiting for post-flight adjustments. This also raises the possibility that a similar setup will be implemented on S-36, forming the foundation for a standardized catching system. Speaking of S-36, its recent progress has been particularly noteworthy. On the 12th of February, the first components of S-36 were spotted, including its nose cone and payload section. The standard feature of this section is the inclusion of the official catching points system. This design closely resembles the catching pins found on Super Heavy, but is smaller in scale. These points align with the square holes seen on S-35, and surrounding them are numerous attachment pins, clear indicators that heat shield tiles will be installed in these areas. A closer look at the structure around the catching pins reveals that it perfectly matches the newly added protective plates. This suggests that SpaceX is iterating on the design in real time, fine-tuning the system before attempting an actual catch. With each new development, it's becoming increasingly clear that SpaceX is meticulously preparing for its first Starship catch. These recent upgrades are likely just the beginning. As the company continues refining its approach, we can expect even more enhancements aimed at ensuring a successful and reliable catching mechanism. The road to that historic moment is nearing its end, and the excitement is only building from here. With these upgrades, how exactly will SpaceX catch ship? The process builds on previous flight procedures. After completing its orbital objectives, ship will begin re-entry, relying on its heat shield for protection. Using its flaps and engines, it'll navigate and decelerate before landing. In ocean landings, this phase usually begins around T plus 45 minutes and concludes just over an hour after liftoff. However, in a catch attempt, ship will complete a full orbit rather than a half circle, significantly extending the timeline. The entire journey could take between an hour and 30 minutes to 2 hours post-launch. With this longer flight, the difficulty increases dramatically. Ship must endure the extreme heat and forces of re-entry before precisely navigating its way to the landing site. Given that the process will likely occur over land, every step must be executed with extreme precision. Just like with Super Heavy, the catch will only happen if mission controllers issue a go for catch command. If any issues arise, the landing will be diverted to the ocean as a backup. Now, let's talk about the critical final phase, navigation and deceleration. After surviving the most intense re-entry conditions, ship's 3 sea-level Raptor engines will ignite. Their gimbal control, combined with adjustments from the flaps, will guide ship back to a vertical position, rapidly slowing its descent. Below, the chopsticks will be in position ready to welcome the return of the king. At this moment, the communication system plays a decisive role. Only if the landing parameters are confirmed will the catch proceed. Ship will carefully approach the launch tower, aligning itself with the chopsticks' grasp. Then, in one of the most daring maneuvers in aerospace history, the chopsticks will close around the ship, making direct contact with its catching points on the landing rail system, just as we've seen with Super Heavy. Simultaneously, the engines will shut down. Once secure, the chopsticks will rotate and lower, placing ship onto its transport stand, and just like that, the mission is complete. If all goes according to plan, this catch attempt will mark a historic milestone, proving that full rocket reusability is possible. This breakthrough could revolutionize spaceflight, drastically cutting costs and accelerating humanity's push toward the stars. If you're as excited as we are, respond with "catch done" in the comment section down below, and don't forget to like the video and subscribe to our channel to stay updated on SpaceX's incredible journey. Beyond preparing the catching points, SpaceX has several other crucial systems to refine before attempting a full ship catch. First and foremost, the re-entry process presents one of the biggest challenges. Unlike Super Heavy, which only needs to survive a brief descent through the atmosphere, Starship must endure extreme heat and aerodynamic forces upon re-entry from orbit. To handle this, the heat shield system requires significant upgrades. After the issues with Ship 29, or S-29 for short, during Flight 4, SpaceX has explored several improvements, likely involving new heat-resistant materials and the possible introduction of an ablative system. These upgrades appear to be carrying over into Ship version 2, with additional cooling systems and metallic tiles undergoing testing. Of course, these enhancements will continue to evolve based on post-flight inspections and real-world performance data. Next, the flap system demands close monitoring. While it represents a major improvement in V2 compared to V1, it has yet to be fully tested in actual flight conditions. SpaceX must assess its effectiveness during upcoming missions, particularly in the high-stress environment of re-entry. The flaps are critical for controlling descent and stability, ensuring Starship maintains the correct orientation before transitioning to the landing phase. If any weaknesses emerge, further refinements will be necessary. The engines are another vital area for improvement. The failure during Flight 7, which cut Ship 33's journey short, underscored the importance of reliable propulsion. Deceleration, navigation, and landing all depend on the engines performing flawlessly. A single failure at the wrong moment could jeopardize an entire mission. SpaceX will need to reinforce the reliability of Raptor engines, ensuring that they can handle the demands of both spaceflight and the intense landing sequence. Beyond Starship itself, ground systems must also be prepared for the catching attempt. Current speculation suggests that Tower B will be used for the first ship catch. The tower is already completed with the first sections of its chopsticks installed and additional orbital launch mount components under construction. The chopsticks, designed to catch Starship as it descends, will be the main focus, requiring precise coordination with the vehicle. Key elements such as landing pins, landing rails, and actuators must be fine-tuned to ensure a perfect match with Starship's catching points. Additionally, the tower's communication system will be reinforced, as it must be in order to prevent abort scenarios like the one seen in Flight 6. Meanwhile, upcoming test flights will be critical for identifying and resolving remaining issues. SpaceX must complete several unfinished objectives, including payload deployment, controlled re-entry, and landing with the latest V2 upgrades. At the same time, previous successes, such as landing Super Heavy and relighting engines in space, must be maintained and refined. Ultimately, mastering a controlled vertical landing for Starship is the final step before attempting a full Mechazilla catch. Each test flight brings SpaceX closer to this historic moment, and the excitement is only growing as these key systems take place. SpaceX faces numerous challenges ahead, but they have a strong foundation to build upon. First, the heat shield system has been significantly improved, allowing ship to endure re-entry with minimal damage. This progress lays the groundwork for further enhancements, ensuring it can withstand the extreme conditions of a full orbital return. The engine system has also shown promising reliability. Aside from the anomaly in Flight 7, ship's engines have performed consistently well. The ability to navigate and decelerate has already been partially demonstrated during ocean landings, giving SpaceX confidence in ship's ability to return safely to Starbase. As for the catch itself, SpaceX has gained valuable experience with Super Heavy's first catch in Tower A. While catching ship will be even more complex, these early successes provide a solid foundation. Over at Tower B, initial tests with the second set of chopsticks have also shown encouraging results, further refining the system. Additionally, SpaceX has one or two more flight opportunities to test and refine both the flight and catch procedures. These remaining tests will be crucial in making the necessary upgrades and perfecting the technique before the historic first ship catch attempt. We are on the brink of another groundbreaking moment in aerospace history. This will be the final step toward achieving full rocket reusability, a milestone that will reshape space travel forever, and it'll all be made possible by Starship, the future king of aerospace. Big news, everyone. SpaceX has just announced major updates for Flight 8, including critical upgrades to address the issues encountered during Flight 7. So what exactly happened in Flight 7 and how has SpaceX responded? Plus, we've got a rare update on the US Space Force's X-37B spaceplane. Flight 8 is just around the corner and preparations for the launch are accelerating. In the latest update, B-15 left Megabay on its transport stand, which had arrived earlier, and headed to the launch site for integration testing. However, it did not have the hot staging ring installed on top, as this component has undergone some unexpected movements. It is likely that SpaceX will install the hot staging ring at the launch site before the flight. Meanwhile, S-34 is expected to make similar moves in the next few days as it continues its final preparations. Beyond hardware progress, other key elements of the mission are gradually being confirmed. As usual, we await official updates from SpaceX regarding the specifics of the flight, and now the company has provided two major updates. The first update confirms the launch schedule and mission details for Flight 8. As previously revealed by Elon Musk, the launch remains scheduled for the 28th of February. Interestingly, road closures for February 26th and the 27th have been revoked, further solidifying the likelihood of a February 28th launch. The planned liftoff time is 5:30 p.m. Central, a schedule that will provide clear visibility of both landing attempts. SpaceX has also announced that the webcast will begin 40 minutes before launch, ensuring fans and space enthusiasts can follow every moment of the mission. The second update, perhaps the most anticipated, addresses the failures of Flight 7, or S-33, in particular, and details the upgrades SpaceX has made to prevent similar issues in future missions. Musk himself called this a Starship technique update, emphasizing SpaceX's commitment to rapid iteration and improvement. At the start of this technical update, SpaceX reaffirmed its ambitious goals for Flight 7, acknowledging the setbacks while stressing that the lessons learned will be directly applied to future Starship vehicles. The company made it clear that these failures are not setbacks, but rather stepping stones toward achieving full and rapid reusability. SpaceX then provided a breakdown of the issues encountered during Flight 7 regarding the Super Heavy booster, which was B-14 at the time. SpaceX noted that one of its center ring engines failed to ignite properly during the boost back burn. The cause of this failure was identified as a low-power condition in the igniter system. Although the engine did eventually ignite successfully during the landing burn, SpaceX is proactively addressing this issue. Future Raptors will feature a pre-planned igniter upgrade to mitigate similar problems in upcoming flights. However, the most significant challenges of Flight 7 occurred with the upper stage, Ship 33. About 2 minutes into the flight, a flash was observed near the aft section close to the Raptor vacuum engines. This part of the ship, known as the attic area, is an unpressurized region between the bottom of the liquid oxygen tank and the aft heat shield. Soon after, another flash was detected, followed by a sustained fire in the attic area. This fire damaged critical components and led to the shutdown of multiple engines. As seen during the flight, the loss of engine function resulted in the complete loss of communication with the vehicle. SpaceX confirmed that the disconnect occurred before the flight termination system was activated, suggesting that the safety system may have been triggered autonomously to bring the flight to an end. Through further analysis, SpaceX determined that the root cause of the problem was an unexpected harmonic response. The stress experienced during flight was several times stronger than what had been observed during ground testing. This amplified stress ultimately led to hardware failure in the propulsion system, causing propellant leaks. Unfortunately, the amount of leaked propellant exceeded the attic's venting capacity, leading to the sustained fires that ultimately doomed the ship. Despite the explosion, SpaceX responded swiftly by executing its debris recovery and safety procedures developed in collaboration with the FAA and air traffic control. or ATC for short. The company confirmed that all debris landed within the pre-planned debris response area, with no hazardous materials detected and no significant environmental impact reported. In the Turks and Caicos region, where debris was widely reported, SpaceX has been actively working with local governments and the United Kingdom on recovery and cleanup efforts. Meanwhile, the FAA, alongside NASA, the Space Force, and the National Transport Safety Board, continues to oversee the mishap investigation. SpaceX is now working toward closing the investigation and obtaining approval for Flight 8's launch. In response to these challenges, SpaceX has implemented several hardware upgrades to prevent similar issues from occurring in future flights. One of the key improvements was demonstrated during the recent 60-second static fire test of Ship 34. This test allowed SpaceX to analyze multiple thrust levels and evaluate 3 different hardware configurations in the Raptor vacuum engine feed lines. By doing so, engineers were able to recreate and better understand the harmonic response issue seen in Flight 7. Additionally, SpaceX has adjusted the fuel feed line configurations for the Raptor vacuum engine's modified propellant temperature settings and established a new operating thrust target for the next mission. To address the attic fire issue, SpaceX has introduced additional venting in the area, as Musk previously suggested. A new purge system utilizing nitrous oxide has also been added to improve resistance to potential propellant leaks. Perhaps most significantly, SpaceX has hinted at integrating Raptor 3 engines on future Starship iterations. This next-generation Raptor design significantly reduces the attic volume, eliminating many of the potential leak points that contributed to the failure of Flight 7. Ultimately, Flight 7 played a crucial role in Starship's ongoing development. Testing at this scale is the fastest way to identify weaknesses and make necessary improvements. SpaceX remains committed to its ambitious vision, continuously refining Starship to achieve full and rapid reusability. Now, with Flight 8 only days away, all eyes are on SpaceX as they prepare for another major test. The question remains, will these upgrades lead to a flawless flight? Do you think SpaceX's improvements will make Flight 8 a success? If you're optimistic, respond with 8 in the comments section down below. That's the number 8, or you can spell it out if you want. Doesn't matter to me, as long as you let me know what you think. And don't forget to like the video and subscribe to our channel to stay up to date with SpaceX's incredible journey toward revolutionizing spaceflight. Upgrades are ready. Now it's time to focus on the flight process. Starting with the first major update, SpaceX has confirmed that Flight 8 will target several key objectives that were left incomplete in Flight 7. These include deploying payloads, conducting re-entry tests in preparation for future catching attempts, and refining previous achievements such as launch, re-entry, catching Super Heavy, and relighting the engine in space. SpaceX also reiterated the upgrades introduced in Starship version 2. Or V2, including changes to the flap design and positioning, an improved heat shield system, increased fuel capacity, and enhancements to the avionics system. The company emphasized that these upgrades are not just crucial for Flight 8, but also pave the way for more advanced missions in the future, such as in-orbit refueling and returning the ship to the launch site. One of the most significant changes for this flight is the reduction in simulated satellite payloads from 10 down to 4. This adjustment helps ease the pressure of the first deployment attempt while maintaining the same size and operational procedures for the payloads. Flight 8 will also place heavy emphasis on testing components for future catching attempts. SpaceX has intentionally removed a large number of tiles to stress test vulnerable areas of the vehicle. Metallic tiles alongside active cooling systems will be installed for evaluation. Additionally, non-structural versions of the catching accessories will undergo initial testing. Another key improvement involves modifications to the heat shield, with a section of the tile line receiving a smoothed and tapered edge to address hotspots identified during Flight 6's re-entry. The re-entry sequence has been specifically designed to push the ship's landing support systems, particularly the rear flaps, to their limits. Radar sensors will also be re-evaluated both during launch and landing to improve measurement accuracy between the vehicle and Mechazilla's catching arms. On the Super Heavy side, the most notable upgrades focus on avionics, featuring a more powerful flight computer, improved power and network distribution, and integrated smart batteries. When it comes to landing, SpaceX is still prioritizing safety. The booster catch attempt will only be conducted if all systems are performing optimally. If any issues arise, SpaceX will opt for a controlled soft landing in the ocean instead. Wrapping up the update, SpaceX also issued warnings regarding noise levels and reaffirmed the critical importance of this test. The company provided a detailed timeline outlining each phase of the mission, which remains largely unchanged from Flight 7. With Flight 8 just around the corner, anticipation is reaching new heights. The excitement is guaranteed, everyone. So, let's go. And now for our final bit of our update today, let's dive into the latest news on the X-37B spaceplane. In a rare public disclosure, the U.S. Space Force has released an image of the X-37B in orbit. The image, made public on February 20th, was captured by a camera aboard the spaceplane while it was flying high above the African continent. The stunning shot features a breathtaking view of Earth against the vast blackness of space, with portions of the X-37B's solar panels and payload bay visible in the frame. According to the officials, the image was taken while the spacecraft was conducting experiments last year. This revelation aligns with the Space Force's stated mission, which is to ensure the health and safety of the vehicle while carrying out its operations. However, beyond its official purpose, the release of this image is significant because it provides the public with a rare glimpse of the highly classified X-37B in action. After more than a year of covert operations, any insight into its mission is a valuable piece of information. What makes this particular mission even more intriguing is that, based on the image and available details, the X-37B appears to be operating farther from Earth than in previous flights. This aligns with expectations given that the spaceplane was launched aboard a Falcon Heavy rocket, a far more powerful vehicle than those used in past missions. Before this flight, the Space Force has indicated that the mission would involve testing new orbital regimes, advancing space domain awareness technologies, and studying the effects of radiation on various materials provided by NASA. One of the more notable experiments reportedly involves aerobraking, a technique that allows the spacecraft to adjust its orbit using minimal fuel by utilizing atmospheric drag. While the X-37B remains shrouded in secrecy, this latest update offers a rare window into its activities. Although we may not see frequent revelations from this classified mission, space enthusiasts will undoubtedly be watching closely for any further updates from the Space Force. The first hardware for Flight 8 Booster 15 has officially made its final move to the Launchpad. There's still plenty of work ahead, but we're getting closer by the day. Stay hyped, everyone. Meanwhile, New Shepard has just wrapped up a crewed suborbital flight, achieving some major milestones along the way. And on the other side of the world, China is gearing up for an ambitious mission to explore the sun. Launch day is approaching fast, and SpaceX is making the final preparations for Flight 8. Every step brings us closer to another groundbreaking moment in Starship's development. After extensive checks and installations in Mega Bay, the first hardware for Flight 8 Booster 15 has officially taken a major step forward. On the afternoon of the 24th, Booster 17 was moved out of Mega Bay, clearing the way for B-15's journey to the Launchpad the following day. What made this move even more interesting was that B-15 wasn't traveling alone. Its hot staging ring was transported alongside it, meaning SpaceX opted not to install it immediately at the production site. The entire movement process lasted nearly 2 hours, marking yet another milestone in the lead-up to the next test flight. Upon arrival at the launch pad, the orbital launch mount moved to the center of the chopsticks, setting the stage for the next crucial step. Around 5 a.m., the lift process began, and just an hour later, B-15 was securely placed on the OLM. SpaceX soon shared stunning images and video of the event captioned, "Super Heavy on the launch pad at Starbase ahead of Starship's 8th flight test." The visuals from afar captured an almost surreal scene. Starbase shrouded in thick fog, creating the illusion of a city in the clouds. Only the booster, the twin towers, and cranes were visible, emerging dramatically from the mist. Given Starbase's coastal location and high humidity levels, this foggy landscape isn't unusual, but it certainly adds to the breathtaking atmosphere of the site. Before this, Musk had also posted a nighttime image of Starbase during B-15's transport, simply captioned, "Starbase, Texas." With its brilliant lights glowing in the darkness, the facility looked like a futuristic city straight out of sci-fi. Now that I've picked my jaw from off the floor, let's return to the technical updates. By the afternoon of the 25th, the hot staging ring was lifted and installed onto B-15. Many have wondered why this wasn't done earlier at the production site. Well, high-altitude footage provided some insight. It revealed two newly installed crossbeams at the top of B-15. It's likely that this structural enhancement was added in Megabay, but required further adjustments before the hot staging ring could be securely mounted. Now, with everything in place, the booster is one step closer to launch readiness. The final major component still missing from B-15 is the FTS, which was spotted at the launch site. SpaceX may install it before or after the upcoming wet dress rehearsal, depending on the test schedule. Meanwhile, progress on Ship 34 suggests that it will soon make its way to the launch site. Following an unprecedentedly long and powerful static fire test, S-34 underwent thorough inspections in Megabay 2. Significant upgrades were likely implemented, as SpaceX outlined in its Flight 8 update, including engine modifications to address issues from Flight 7, heat shield improvements, and more. The FTS has already been installed, and the ship is likely awaiting the integration of its PEZ dispenser system and 4 simulated satellite payloads. Once these final touches are complete, it'll be ready to join B-15 at the Launchpad. This move could happen as soon as tomorrow to keep the launch schedule on track. With both stages in place, SpaceX will proceed with the wet dress rehearsal. This test will simulate a full launch countdown, including venting all systems and loading fuel into both stages' tanks. Additionally, the water deluge system will likely undergo a test run to ensure optimal performance. Once the wet dress rehearsal is complete, a destacking process will probably follow to allow for final checks on both engines. Afterward, the ship and booster will be restacked, signaling the beginning of the official launch countdown. Despite all the progress, one major factor remains outside SpaceX's control: the approval from the FAA. In its latest update, SpaceX stated, SpaceX is working with the FAA to either close the mishap investigation or receive a flight safety determination, along with working on a license authorization to enable its next flight of Starship. In any case, SpaceX must continue pushing forward, ensuring that both the hardware and ground systems are fully prepared, while also navigating the regulatory process. For all of us following this journey, it's time to get excited once again. If you're ready for Flight 8, comment "Let's go 8" down below. And of course, don't forget to like the video and subscribe to our channel to stay up to date on SpaceX's latest developments. Your support means everything. It's what drives us to continue delivering the best coverage of SpaceX's journey. As the company works toward its ambitious long-term goals, we're also striving to grow, with our immediate goal being 200K subscribers. We know there's more work ahead, but with your support, we're confident we'll get there. So if you haven't already, hit that subscribe button and join us on this incredible adventure. In other news, Blue Origin recently marked another milestone in its suborbital spaceflight program with the successful launch of New Shepard's NS-30 mission. After a slight delay, the mission lifted off at 10:50 a.m. Eastern or 9:50 a.m. Central from Blue Origin's Launchpad in West Texas. Everything proceeded smoothly with updates shared by Blue Origin on X, including footage of the astronauts' experience, the booster's landing, and the capsule's parachute-assisted descent. According to the company, the entire flight lasted 10 minutes and 8 seconds, reaching a maximum altitude of 107 kilometers. Shortly after, Blue Origin proudly announced on X, "We just completed our 10th human spaceflight and the 30th flight of the New Shepard program." The astronaut crew included Lane Bess, Jesus Calleja, Elaine Chia Hyde, Dr. Richard Scott, Tushar Shah, and an undisclosed 6th person. This was Lane's second flight. To date, New Shepard has flown 52 people to space, with 4 individuals flying twice. Blue Origin CEO Dave Limp added, "Congratulations to our astronauts and the Blue Origin team on the successful NS-30 launch. 10 crews, 52 people, including 4 repeat customers, have now journeyed to space on New Shepard, each with an unforgettable experience. The 6-person crew named themselves Perfect 10 to commemorate New Shepard's 10th successful human spaceflight. Notably, this marks New Shepard's 30th mission overall, with 29 of those being successful. Additionally, the flight came just 3 weeks after NS-29, showing an impressive turnaround time for Blue Origin's suborbital tourism program. For Blue Origin, successful crewed missions are critical in maintaining competitiveness in the suborbital tourism market, particularly against rivals like Virgin Galactic. However, if the company truly aims to establish itself as a major player in the broader space industry, its orbital rocket New Glenn must also succeed. While New Shepard flights demonstrate consistency, the company still faces significant challenges in proving its ability to operate beyond suborbital tourism. Interestingly, some observers have noted that recent New Shepard flight schedules seem to coincide with SpaceX's Starship launches. While this could simply be coincidence due to both companies increasing their launch cadence, some speculate that Jeff Bezos and his team may be strategically timing these flights to divert attention from SpaceX's groundbreaking Starship program. While this theory is amusing, given that New Shepard and Starship operate at vastly different levels, it does raise questions about Blue Origin's long-term ambitions in the space industry. And for our final entry of today's updates, moving from suborbital space tourism to deep space exploration, China has announced a bold new mission targeting the sun's poles. According to a recent disclosure on X, China is planning to deploy the Solar Polar Orbit Observatory as part of its National Space Science Medium and Long-Term Development Plan 2024 to 2050. This ambitious project is currently slated for launch in 2029. The mission will utilize Jupiter's gravitational pull to alter its trajectory, allowing the spacecraft to enter a high-inclination orbit around the Sun. This will enable the observatory to gather crucial data on solar magnetic activity cycles and high-speed solar winds, which have a direct impact on Earth's space weather and technological infrastructure. Exploring the sun's poles is a highly challenging endeavor. Spacecraft typically remain within the plane of the ecliptic, or the flat disk-like region where most planets orbit. Very few missions have ventured beyond this plane to study the sun from above and below. China's upcoming spacecraft is expected to achieve an inclination of 60 to 70 degrees, a remarkable feat. In comparison, NASA and ESA's Ulysses mission, launched in 1990, managed to reach 80 degrees. To achieve its ambitious goals, the Solar Polar Orbit Observatory will be equipped with a sophisticated suite of instruments designed to study the sun's magnetic activity, solar winds, and high-energy phenomena. These include a magnetic and helioseismic imager to analyze solar magnetic fields, an extreme ultraviolet solar telescope to observe solar flares and coronal activity, and both a visible light coronagraph and a very large angle coronagraph to study the sun's outer atmosphere by blocking its bright surface. Additionally, a low-frequency radio spectrometer will detect radio emissions from solar storms, while an X-ray imaging telescope will capture high-energy solar events. The spacecraft will also carry a solar wind ion analyzer and an energetic ion analyzer to measure charged particles emitted by the sun, along with a magnetometer, to study the sun's magnetic field and its interactions with the solar wind. Together, these instruments will provide groundbreaking insights into the sun's behavior and its effects on space weather. The mission highlights China's growing focus on expanding its reach in space science. Starship is only going to become more advanced and more powerful. In the future, this mighty spacecraft will be equipped with up to 35 Raptor engines, a level of thrust almost beyond imagination. It's hard to picture any Launchpad system capable of withstanding such raw power, but that's just how the average mind sees it. SpaceX, on the other hand, has already devised a brilliant solution to tackle this challenge. So, what groundbreaking technology do they have up their sleeve? Since the installation of the water deluge system, it has consistently demonstrated its reliability in shielding Stage 0 from intense heat generated during Starship launches. However, the system is now poised to face an unprecedented challenge. An environmental impact report submitted by SpaceX for launching 44 Starship flights at LC-39A, published by the FAA in July of 2024, outlines SpaceX's proposal to launch Starships configured with up to 35 Raptor engines for the Super Heavy booster. This upgrade is crucial as SpaceX plans to develop Starship V3 with up to 10,000 tons of thrust at sea level. While this is an impressive number, the sheer power of 35 engines carries with it a significant risk: the potential to destroy the launch pad beneath it. A quick glance at what occurred during the first test flight of Starship helps illustrate this danger. The launch caused extensive damage to the pad and surrounding infrastructure, leaving a large crater in the concrete beneath the launch mount, which debris from the pad was sent flying for miles. So how does SpaceX intend to avoid a repeat of this destructive event? Fortunately, the company seems to have found a solution. Musk revealed on X last year that the new Launchpad is already designed to withstand the forces generated by a 10,000-ton thrust version of Starship, which, he pointed out, is almost exactly 3 times more powerful than the Saturn V moon rocket. This new pad, under construction at Starbase since last year, represents a monumental step forward. It's not just a facility to support SpaceX's ongoing Starship project, it is also equipped with cutting-edge systems to handle future versions of the spacecraft. To fully appreciate the upgrades, we need to take a closer look at the technologies integrated into the current Launchpad. The first critical component is the orbital launch mount, the platform where Starship sits during liftoff. The OLM features 20 clamps designed to securely hold the booster in place prior to launch, as well as a quick disconnect system that provides both liquid fuel and electricity to the vehicle. Given its direct exposure to the heat generated by the 33 Raptor engines, the OLM's entire structure, from the deck to the legs, is heavily shielded to withstand the extreme temperatures. As SpaceX pushes the boundaries of what's possible with its Starship program, these advancements in infrastructure will be vital for ensuring the continued success and safety of future launches. To enhance the protection of the launch ring surface, thick steel plates were added to the deck. These plates serve a dual purpose. They shield the underlying electrical cables and help minimize the thermal load transferred into the structure. In addition, a protective enclosure was placed around the booster's quick disconnect, accompanied by a cover for the flexible propellant and gas distribution lines. Just before liftoff, the quick disconnect folds inside its protective cover to safeguard the critical components. To prevent damage to the launch pad and surrounding infrastructure with every launch and to protect the nearby facilities, a water deluge system has been in place beneath the orbital launch mount since the first Starship flight. The system features a reinforced steel plate that sprays large volumes of water upward, with Musk comparing it to an upside-down showerhead. The water is sourced from a nearby deluge tank farm, which uses compressed gas to propel water into the steel plate beneath the OLM. This setup not only dissipates heat from the Raptor engines, but also absorbs shock waves and noise, significantly reducing the impact of the rocket's thrust on surrounding facilities. However, despite its effectiveness, SpaceX has recognized that this system isn't performing at the level they require for long-term success. Following the Starship flight, there was still noticeable damage to the steel plate and some pipes that needed replacing. While the damage was relatively minor, considering the frequency with which Starship launches are expected to take place, potentially multiple times a day, this wear and tear could undermine the company's ambition of achieving rapid reusability. To address this, SpaceX has opted to implement a new system at Pad B. This system is not entirely new, as it has been used in the past by NASA, but it represents a significant upgrade. The flame trench. A flame trench is designed to redirect and dissipate the intense heat, flames, and exhaust gases generated by rocket engines. Its primary goal is to protect equipment, infrastructure, and the surrounding environment by preventing damage from the fiery emissions. In this system, the rocket's flames pass through openings in the Launchpad and are directed toward a flame deflector within the trench, which extends well beyond the Launchpad itself. To further mitigate noise, a water-based sound suppression system is often integrated. The diverter, a durable heat-resistant structure, channels the force of exhaust gases and flames away from both the rocket and the surrounding equipment. This redirection is crucial for minimizing damage from the high-temperature gases and reducing the acoustic impact during ignition, ensuring both the integrity of the launch infrastructure and the success of future launches. The flame trench system that SpaceX uses is uniquely designed, diverging from traditional setups. While NASA used a similar system during the Apollo program, SpaceX has made significant improvements and adaptations for its own needs. NASA's design at Kennedy Space Center's Launch Complex 39 involved a two-way wedge-shaped metal flame deflector. This deflector stood 13 meters tall and 15 meters wide, weighing an impressive 317 tons. The proximity of the water table to the surface of the ground played a crucial role in the design, leading engineers to place the bottom of the flame trench at ground level. This flame deflector and trench ultimately shaped the dimensions of the octagonal-shaped launch pad, highlighting its importance in the design of rocket launch facilities. SpaceX's dual flame trench system follows a similar approach but is refined for modern needs. The design allows heat to be diverted to both sides, utilizing numerous steel pipes that form a flame bucket. Water flows through these pipes and is released through small holes along the tubes, effectively cooling the system. This method, which is already in use at Massey's and McGregor's new vertical test stands, is a critical component of SpaceX's infrastructure. The trench itself is excavated down to the designated floor level, where a stabilizing layer of concrete is applied to maintain structural integrity and provide a solid foundation. Moreover, the design of the orbital launch mount at Pad B incorporates significant changes compared to its counterpart at Pad A. While Pad A's OLM is equipped with hold-down arms and clamps to secure the Super Heavy booster, Pad B's OLM takes a more robust approach. It is designed as a giant square and includes a water-cooled steel plate on its topmost level. This addition, along with the dual flame trench, plays a critical role in dissipating the immense heat generated by Starship's 35 Raptor engines during launch. Together, these systems provide essential protection for the facility, mitigating the destructive power of Starship V3's thrust. Ultimately, this innovative design could help make SpaceX's vision of rapid, frequent launches a reality, enabling the company to achieve what once seemed impossible. To support future versions of Starship, SpaceX is making substantial upgrades to various facilities, with the launch tower being one of the most notable. Along with the installation of a reeving cable on the tower to facilitate the placement of the main cable for vertically moving Mechazilla's chopsticks, a traveling block has also been added. For those unfamiliar, a traveling block is a key component in a block and tackle system. It is equipped with a set of pulleys or sheaves through which the drill line or wire rope is threaded. Positioned opposite and below the stationary crown block, the traveling block works in tandem with the crown block and drill line to lift extremely heavy weights. On larger drilling rigs, this system can support weights in the hundreds of thousands of pounds, with line tensions even exceeding 1,000,000 pounds when raising or lowering a derrick. While traveling blocks are commonly used on oil rigs, SpaceX has adapted this system to move Mechazilla's massive metal chopsticks, which are responsible for lifting both Super Heavy and Starship onto the launch mount as well as catching them upon landing. At Pad B, SpaceX made a crucial change to the traveling block, increasing the number of reeving loop slots from 5 to 7. While this modification may slightly reduce the speed of the arm's movements, it significantly enhances the weight capacity of the tower, allowing it to support the increased mass of future Starship models. This upgrade is especially important because Starship V3 will be significantly taller and heavier than its predecessors. With the Block 3 thrust upgrade, the rocket is expected to carry payloads of up to 200 tons to orbit, meaning the launch tower must be able to support these much greater weights. Although some have suggested that the change in the traveling block could slow down the arm's movements, Musk has stated that the tower arm will be shorter, enhancing its maneuverability and speed. Therefore, any perceived reduction in speed is expected to be minimal, and the overall system will remain highly efficient. It's clear that SpaceX has thought through every detail of this upgrade, from the increased weight capacity of the traveling block to the adjustments made to ensure the tower's speed and maneuverability. It's evident that SpaceX is preparing for the immense challenges of launching even more powerful versions of Starship. With these upgrades in place, the company is not just preparing for future missions, they're shaping the future of space travel itself. It seems that Starship V3 is far from the final version of this groundbreaking spacecraft. In a tweet, Musk hinted at a future iteration with a significantly larger diameter. Following an increase in Starship's height. He wrote, "There will probably be another 10 meters added to the Starship stack before we increase diameter." A vehicle of this scale would require much more than the current infrastructure can offer. To accommodate such a massive design, SpaceX would need to develop a dedicated Launchpad, a separate Mechazilla system, and possibly its own manufacturing facility. Alternatively, this next-gen Starship could be constructed in the Gigabay planned for the Florida facility, further solidifying SpaceX's vision for future space exploration. Essentially, this would be a completely new vehicle, marking a major leap forward in space technology. Regardless of which version comes next, there's no doubt that Starship will become the centerpiece of space travel for years to come. SpaceX's commitment to continuous innovation means that they will not shy away from embracing the latest technological advancements. As the company pushes the boundaries of what's possible, the next steps in the Starship program will undoubtedly be thrilling. Whatever comes next, it's clear that the future of space exploration is in capable hands, and the world will be watching. SpaceX has just taken another unbelievably groundbreaking step to make Falcon 9 even more powerful. How long can its dominance continue? And speaking of Falcon 9, we finally have the first updates on the previously lost upper stage. What really happened, and could this impact SpaceX's operations? I want you to take a look at this video. This is the moment when Falcon 9 landed on the drone ship. Everything seems normal, right? But did you know, this is a major stride for SpaceX. Over the past decade, SpaceX has established itself as the dominant force in the aerospace industry, and the Falcon 9 has been at the heart of that success. This rocket has proven itself with unparalleled reliability, an ever-increasing launch cadence, and most importantly, groundbreaking reusability. These factors combined have given SpaceX a major edge over competitors. But here's the thing. I'm talking about the Falcon 9 as we know it today, operating from U.S. launch sites in Florida and California, with landings taking place either on solid ground or aboard drone ships in U.S. or international waters. That's been the standard for years. Now imagine if Falcon 9's operations became more international. What if it could take off from one country and land in another? That would open up a whole new world of possibilities, and that's exactly what just happened with this historic landing. This particular mission marked the first time SpaceX landed a Falcon 9 in foreign waters just off the coast of the Bahamas. The rocket lifted off from SLC-40 at 6:21 p.m. Eastern on February 18th, and after an 8-minute journey to space, Booster B-1080 successfully landed on the drone ship, which had been strategically positioned near the Bahamas. You might be wondering, how was SpaceX able to do this? According to reports, this is part of an agreement SpaceX has reached with the Bahamas, a partnership that is mutually beneficial. The Bahamas' Deputy Prime Minister Isaac Chester Cooper joined the SpaceX livestream to highlight just how important this collaboration is for his country.
This is significant for the Bahamas in so many ways. The first international landing in the Bahamas, in the Exuma Sound, is significant in and of itself. It puts us at the cutting edge of innovation, and it gives us a small country of 400,000 people to an opportunity to participate in the aerospace industry. This is huge.
For a nation like the Bahamas, which has never had direct involvement in spaceflight, this is a rare and valuable opportunity to take part in the future of aerospace. Not only does this collaboration put the Bahamas on the map in a high-tech industry, but it also has the potential to boost tourism and the local economy. Of course, safety remains a top priority. Cooper reassured the public, stating,
We recognize that it's important that safety is put first and foremost, and we have ensured that we have done the due diligence and we've done our work to deliver this first international landing in the Exuma Sound.
From SpaceX's perspective, this new landing location is a game changer. As the company pointed out in a tweet, landing in the Bahamas allows Falcon 9 to maximize its launch performance. Here's why. The Bahamas are located southeast of Florida, making them an ideal spot for missions launching on a southeast trajectory. This allows SpaceX to take full advantage of the Earth's rotation, improving efficiency and increasing the number of satellites that can be delivered to orbit in a single mission. It also means the future Crew Dragon missions, like the upcoming Fram-2 mission to a polar orbit, could benefit from this optimized flight path. There's another key advantage: weather. The Bahamas' climate offers more stable conditions, especially in winter, which means fewer delays and a more reliable launch schedule. By adding the Bahamas as a landing option, SpaceX can keep up its rapid launch pace even when Florida's weather is less cooperative. And then there's the bigger picture. This is the first step toward fully international Falcon 9 operations. Until now, SpaceX has launched payloads for customers all over the world, but the actual launches have always taken place in the US or over international waters. By successfully landing in another country's territory, SpaceX has proven its ability to operate across borders, setting the stage for even bigger expansions. As Kiko Donchev, SpaceX's vice president of launch, put it, this launch is special as it will be the first time a rocket launches from one country and lands in another, one step closer to making spaceflight aircraft-like. Historically, a few other rockets have launched from one country and landed in another, Rocket Lab's Electron, for example, which takes off from New Zealand. But Falcon 9 is in a league of its own. Its reusability, payload capacity, and launch frequency make it the most competitive orbital rocket in the world. And by expanding its operational reach, it's pulling even further ahead of competitors like Blue Origin's New Glenn, ULA's Vulcan, or ESA's Ariane 6. This move increases SpaceX's flexibility both in terms of scheduling and launch locations, making it an even more attractive option for customers around the world. And let's be clear, this is likely just the beginning. The Bahamas is the first step, but SpaceX could eventually expand this concept to other countries, and not just for landings. This opens the door for launches outside of US soil, further decentralizing global access to space. And don't forget about Starship. SpaceX has an ambitious long-term vision for Earth-to-Earth travel, where Starship could act like a commercial aircraft, transporting cargo and passengers to any point on the planet within an hour. If Falcon 9's operations are already expanding internationally, it's not a stretch to imagine that Starship could follow a similar path, revolutionizing not just space travel, but global transportation itself. So what do you think? Is this the future of spaceflight? Would you like to see SpaceX expand this concept to even more countries? If you support this move, type "Let's do it" in the comments section down below. Then, like the video and subscribe to our channel to stay updated on SpaceX's incredible journey. Falcon 9 has once again made headlines, but this time it's not about another record-breaking launch. Instead, it's about an update on the lost upper stage from a mission in early February. A recently shared image on X has revealed what appears to be a blackened fragment, most likely a composite overwrapped pressure vessel, which crashed near Poznan, a city in western Poland. This assumption is based on the fact that the image was posted by an account named Poznan Moment. Analyzing the image, the COPV seems to have landed near a rural house, as indicated by the presence of an iron gating, a wooden object, and a pile of grass behind the debris. Fortunately, no reports have emerged of any injuries or property damage caused by the impact. If this indeed is a piece of Falcon 9's upper stage, it suggests the hardware underwent a chaotic journey. Instead of re-entering and burning up in a controlled manner, the second stage may have veered off course after losing control, altering its trajectory significantly. The COPV itself appears heavily damaged, likely due to the intense forces of atmospheric re-entry. This component plays a critical role in the second stage of Falcon 9, storing helium at a pressure of 6,000 psi to pressurize the large propellant tanks. Because of its importance, SpaceX will undoubtedly analyze the debris closely to determine what exactly went wrong during the mission. It wouldn't be surprising if SpaceX dispatches a team to the crash site soon to examine the remains and bring them back for further analysis. This incident will help engineers better understand the failure and improve future missions. Naturally, this update might also draw the attention from the FAA. The situation is somewhat reminiscent of the recent event where debris from Starship's S-33 was found in areas along its flight path, prompting a mishap investigation. Could Falcon 9's case trigger a similar response? In my opinion, that seems unlikely. There have been previous incidents of COPV debris returning to Earth, such as in 2021 when a similar object crashed into a farm in Washington. Additionally, despite the issue with this particular mission, other Falcon 9 flights have continued without any problems, suggesting that this was an isolated case rather than a systemic failure. As long as SpaceX ensures public safety, ongoing launches are likely to be affected. That said, the FAA's stance will be crucial. How they respond could determine whether any new regulatory actions are taken regarding Falcon 9's upper stage. For now, all eyes are on SpaceX and the latest developments surrounding this unexpected update. Obviously, with such an update, many people believe this poses a challenge for SpaceX. That's not entirely wrong, but if we take a different perspective, it actually reinforces the strategy that SpaceX has been pursuing all along: full reusability. Right now, Falcon 9 is still only partially reusable. While the booster and fairings can be recovered and flown again, the second stage remains expendable. This is what sets Falcon 9 apart from every other operational rocket. It holds an unmatched record in reusability, making it the dominant force in the industry. However, because the second stage is not reusable, it ultimately burns up in the atmosphere. Ideally, its re-entry is controlled to ensure debris lands safely in the ocean, away from populated areas. But no system is completely flawless. While rare loss of control events can happen, leading to unpredictable risks. That's why tighter control over the second stage is becoming a priority. And the ultimate solution to this issue is full reusability, not just of the first stage, but of the entire rocket. We've already talked at length about the benefits of full reusability, which include faster launch turnaround times, drastically reduced production costs, and a revolutionized space industry. But there is another crucial advantage: risk reduction. By focusing on recovering and reusing the upper stage, SpaceX will gain more control over every part of the rocket, significantly minimizing the risk of uncontrolled re-entry events. This effort is already in motion with Starship, the rocket SpaceX is developing for the future of spaceflight. Unlike Falcon 9, Starship is designed for full reusability from the start. SpaceX plans to catch the upper stage, the ship, using the Mechazilla arms, just like they intend to do with the Super Heavy booster. In the future, additional landing methods, such as recovering Starship on a drone ship, could also be implemented. And as SpaceX expands its international operations, as seen in the recent Falcon 9 mission to the Bahamas, the groundwork is being laid for a future where full reusability is standard. The first major steps toward this goal are set to take place early this year. Now, it's just a matter of seeing how SpaceX executes its vision and whether it can unlock the full potential of this game-changing capability. This has been Kevin with Great SpaceX. Don't forget to like the video and subscribe if you haven't already to stay up to date with yours truly in the latest details of SpaceX's progress. Thank you so much for tuning in, and remember, curiosity, imagination, and inspiration will always follow you as long as you keep looking up.